Hello and welcome back. Today we're going to take a look at cyber deception. We'll be going through some slides, and in the next video, we'll actually deploy some cyber deception technologies and have a look at how they work. So, what is cyber deception? It's the use of decoys or tokens, or otherwise called honeypots, to try and lure bad actors to engage with fake assets that we've set up. What are the goals and benefits of cyber deception? We want to slow down the threat actor. We want to try and disorientate them. We want to redirect them away from our real assets. And while we're doing this, we want to gather real time threat intel. We want to be able to detect and respond faster. And we also want low false positives. So, why use cyber deception? A lot of the TTPs and IOCs that we use in our security controls are coming from industry or media sources or maybe from the dark web. But a lot of the time, they're coming to us after an attack has already occurred somewhere else. Sometimes these are not entirely applicable to our environment, and sometimes they could be a little bit aged. So, by using cyber deception technologies, we can actually gather real time threat intel. As the threat actors are interacting with our technologies, we can gather that threat intel. We can proactively guide the threat actors away from our critical assets, and we can start to prioritize the actors that are actually acting on our environment. We can understand who's trying to interact with our environment, and we can start to build defenses accordingly. The obligatory pop culture reference. It's a good example of cyber deception. So, Terminator Salvation. Skynet has created a signal which is supposedly capable of deactivating all of the machines, and it leaked that existence of that signal to the resistance. The resistance leader took this to be true and attempted to use that signal to shut down the defenses of Skynet. However, the signal actually allowed Skynet to track down their headquarters and destroy it, which killed the resistance command. The OODA loop. This was developed by John Boyd, who used it for fighter pilot training. Humans move through the OODA loop for all situations. It consists of four phases: the observe phase, the orient phase, decide phase, and the act phase. In the observe phase, it's about information gathering. You're collecting information about the situation. In the orient phase, you're starting to build a hypothesis of the situation, starting to do analysis of the information you've gathered, and starting to uh, think of a way ahead. In the decide phase is really where you're planning, and in a cybersecurity situation, you could be weaponizing a payload, or you could be developing defenses. In the act phase, this is the actual execution of the plan, which could include deployment of new technologies or the actual attack. Threat actors and defenders all move through the OODA loop. The goal is that as defenders, we want to move through the OODA loop faster than the threat actor does. By deploying deception technologies, we can disorientate the threat actor. We can make them question what's true in our environment and what's not true. And we can keep them in that observe phase. We can also disrupt their um, actions. So they can never actually execute the attack. By doing this, we keep interrupting the ability of the threat actor to move through the OODA loop, while ourselves, we can move through much faster, we can gather real time information, and we can start building our defenses. So, how do we deploy a cyber deception campaign? MITRE have come up with the Engage framework. Included in that is a 10-step process organizations can follow to build out a successful deception campaign. I'll do another video on the MITRE Engage framework, so subscribe and like and keep an eye out for that one. Different types of deception technology. Probably the simplest is token based. Things like deceptive files, web bugs, other bits and pieces that you can deploy quite simply into your environment. An example of these is canary tokens. They're very easy to create, and you could leave them sitting in a file share, for example. And once someone interacts with that file, it'll trigger. Appliance based, still fairly inexpensive, still fairly easy to deploy, but does require an integration into your network. And these can be used to simulate specific environments. Enterprise level can be a lot more complex and can even be an entire replica of a production system. The goal here is to have a high level of realism so that the threat actor believes they're moving through the production network, but in reality, we're collecting information about them and we're redirecting them away from our critical assets. So, with honeypots, there's different levels of interaction. So, low interaction is something like a simple port listener where the threat actor connects, but there's not a whole lot of interaction with that service. Medium interaction with something like Cowrie, as an example, is where attacker communications are actually analyzed and simulated responses can be delivered back to the threat actor to replicate a real service. And we'll see that in the next video when we deploy Cowrie. And high interaction, which can involve the use of real services or completely operational hosts or even completely deceptive networks. So, who can use deception technologies? Realistically, companies of all sizes can take advantage of deception technologies, even if it's something as simple as a canary token. The main thing is to make sure you have a use case and a plan and ensure you can monitor and log the results. In the next video, we'll deploy Cowrie and we're going to have a look at how we can interact with Cowrie and the different features it has to make the service seem more realistic. Thank you, and I look forward to seeing you on the next one.